the goal is to factor something, okay? When we say factor, we want to pull out as many things as we can. We want to pull out the maximum number of things, which is also called the GCF, okay? Greatest common factor. We did this for numbers. So for example, I don't know if you remember this, for 10 and 4, what would be the greatest common factor?
2.
Yeah, exactly. How did you get that? All right, let's spice this up. What about for 50 and 10?
5.
No, that's not the greatest. It's gonna be 10, okay? Right?
Oh,
Because
okay.
10 goes, but it's sometimes it's easy to see and sometimes it's not. To see it for numbers anyways, this is grade 8, right? So for numbers, you want to find the prime factorization of it. So for example, 10 is divisible by 2 and 5. So 10 is 2 times 5. If you look at 50, it's the same thing, right? You first start with a 2, you get a 25, and then you get a 5 and a 5, like that. So this is called prime factorization, okay? 2 times 5 times 5. And whatever they have in common, that's going to be your GCF. So these two have 2s and 5s. So the GCF is going to be equals to 2 times 5, 10. Now, if you want the LCM, which is called the lowest common multiple of it, you just take the GCF 10, and then you multiply it by whatever is remaining, 5. And there we go, 50. Okay?
Okay.
That's how we do it for number. This thing is called prime factorization. But now we're going to be doing it with like letters and expressions. So look at these two expressions, 3x squared minus 6x. What can we pull out? We can pull out a 3, okay, because they both have 3 is divisible by both these. What else can we pull out?
A 6.
No, we can't pull out a 6 because 6 does not go into 3. Okay. 3 goes into itself and 6. That's why we pulled out the 3, but we can't pull out a 6. Look at the letters. They both have x's, yeah?
Mm-hmm.
So we can pull out 1x because this one has 2 x's, this one has 1. So the maximum things we can pull out is 1x. And the question is, what are we left with in this bracket? (3x), we took out 3x out of 3x squared, yeah? You're just left with an x there. We took out 3x out of 6x, so you're left with a 2 there. Now, how do you find these guys? You just do the division. So we have 3x squared. We took out a 3x. Look at this, 3 and 3 cancels out. And x squared and x, when you do this, you just get 1x, okay? And same thing with the other one, 6x over 3x. Well, the x's cancel out, and 6 over 3 is a 2.
Mm-hmm.
Cool?
Uh-huh.
What's x2 times x3? Two options, x6, x5, or 5x. Actually, 3 options. Only one of them is right.
5?
5x?
No, x5.
x5 is correct. Yes, x5 is correct. So another way of looking at this is you've pulled out a 3x. How do you get 3x squared? Well, you just got to multiply it by an x.
Mm-hmm.
Like that. Okay. It'll get difficult as we go along. Let's try doing these two. The first one's pretty basic. So we have 10a cubed and 25a squared. What can we pull out? What do they both have in common? We're looking at 10a cubed, yeah? And 25a squared. What's the greatest common factor between 10 and 25?
5.
Yeah, you can pull out a 5. And what's the maximum number of a's you can pull out?
8.
A1, A2, or A3?
A2.
Yeah, exactly, A2. That's the maximum you can pull out. Now the question is, what goes in this bracket? We had 10A cubed, we pulled out 5A squared. So you need a 2 here, yeah? To get
Mm-hmm.
that 10. How many A's?
Just one.
Just one, exactly. Look at the other term, 25A squared. What goes here?
5.
Yeah, 5. And how many A's?
Also one.
No, none. Because 5A squared times 5 is 25A squared.
Oh, okay.
Yeah, if we had an A here, that would be 25A cubed, okay? Like that.
Mm-hmm.
But we don't have 25A cubed. And there we go. So that's how you factor that. Let's look at the other expression here. We're gonna do this step by step. How many, look at the numbers. So 9, 12, and 6. What's their greatest common factor?
3.
Yes. How many x's? We have x4, x3, x2. What's the maximum x we can take out?
3.
No, not 3. Because x3 doesn't go into x squared, okay?
Oh,
You can take out 2 of them because x squared goes into x4, x3, and into itself. How many y's can we take out?
also 2.
Yes, that's correct. So what goes here?
Um, 3x squared.
Yeah. Any y's?
Y squared.
Yes. What about the next term here?
4x.
Yes, that's right. And now we're done with this because we already have y2, y2. What about the last one?
Is it just 2?
Not just 2. There is a 2 there. What about, look at the y's. We took out 2. It's 3 of them here.
So just 1 Y?
Yeah, just one y and you're done. Okay.
Okay.
That's called factoring. You just kind of pull things out. You can just do it step by step. What if there's more than one thing though, like in this one? This example is pretty dicey. Before doing this, let's do this. If you have 5xa minus 3a, what can we pull out?
You can pull out an A.
Yes, what are you left with in the bracket?
5x minus 3.
Correct, easy as that, okay? Now in this example A, we're gonna treat this bracket as an A, okay? Notice how they both have that bracket in common. So we're gonna pull out that entire bracket. That's gonna look something like this. X minus 2, we've pulled it out. What's left? So we pulled out the bracket. What else is left?
5x minus 3.
Yes. Okay, you understand that?
Mm-hmm.
So we're able to pull out a bracket. Doesn't matter how many terms are there in this bracket. Could be plus y cubed, plus z, whatever. As long as they have that in common, we can pull that entire bracket out. Let's try doing another one. What about this one? If you look at this one, they don't have anything in common, not all four of them. They're four distinct terms. So for a question like this, we are going to kind of chop it in half. Look at the first two. What do they have in common?
And A.
Right. What are we left with in the bracket?
X minus Y.
Correct. Now let's look at the next two terms. What do they both have in common?
A 5.
Yes, a 5. You see this sign? That sign is going to drop. Okay, we can pull out a 5. What do we have in the bracket?
X plus Y.
All right, so here's the tricky part, okay? We're pulling -5 out. You see there's a -5 on the outside? It'll be x minus y, because -5 times minus y would give us a plus 5y. Right?
Oh.
We pulled out a -5. Look at this. 5y over -5 is -y. Okay? So that's the part that we have to be careful. And then look at this. They both have this bracket in common, right? X minus y. We can pull that out. And that's the goal. When you do a question like these two brackets have to be the same. That's why we pulled out a -5. We could have absolutely pulled out a +5, something like this, +5. But if you do this, you're going to get -x plus y in the bracket. And these two brackets are not the same. So that's why the preferred method is to take out the -5 so we can have the same bracket and we can pull out that bracket. Okay? So if you understand that, let's try doing some problemos. So they've given us a trapezoid. All right. If you remember, what's the area of a trapezoid? Any ideas what the area of a trapezoid could be?
The what?
The area of a trapezoid. What's the formula for the area of a trapezoid?
Does it have to do with like 2 bases instead of 1?
Yeah, it does. So it works like this, okay? So this is, we can call this A, we can call this B, we can call this H, the height. The area of a trapezoid is equals to A plus B divided by 2 times the height. Okay? You gotta add them up, divide by 2, and then, yeah, multiply by the height. So now this is gonna turn into an equation. They have given us the area. That's 70b plus 10. And we're gonna add these up. So A is 3b plus B is 4b plus 1 divided by 2 times the height. There we go. Something like that. How do we solve this equation for height, for h? It's gonna, the answer will be in terms of b. H will be something something b. I'm not gonna get a number out of it. All right, look at this. In the numerator, we have 3b plus 4b. Those are like terms, so we can just straight up add them. So we get 7b plus 1 over 2. And then you have 70b plus 10, and then times the height. We're trying to isolate the height. We need to get rid of this term. What do we do on both sides?
You multiply?
multiply by 2. Is that right? Yeah, we first multiply by 2. So now the denominator is gone. Now what do we do?
Um,
We need to get rid of this term. Just divide, right? We're trying to isolate for h for this term. We're gonna get rid of that. Right now it's being multiplied, so we would just divide by that on both sides. There we go. This cancels out, and that's the height in terms of b. Did you understand that?
okay. Mm-hmm.
There we go. Area of a trapezoid is the sum of the two lengths times the height. And why is that the case? I mean, you can always turn this into a rectangle, yeah? And
Uh-huh.
then two smaller triangles. And that's where it comes from, but it's good to just remember what it is. Let's see if there's anything dicey. Nope. All right, let's try doing something that we have done. It basically comes out to the thing that we just did. So the goal is to factor this, okay? The goal is to factor this expression. And factoring it is very powerful. I'll tell you why in a second. But now notice they have nothing in common. The three terms, they have absolutely nothing in common. How do you factor something like this? We're going to use the man method. Okay, the man method. Now what is the man method? We're looking for a set of numbers. When you multiply them, you would get the product between the first coefficient and the last coefficient, which is a 12. 1 times 12 is a 12. And when you add them up, you get the middle coefficient of 7, always. What are the two numbers that satisfy these conditions? When you multiply them, you get 12. When you add those two numbers, you would get a 7.
Um,
It would be
3 and 4.
yeah, exactly. It's going to be 3 and 4, okay? And those are our
Mm-hmm.
numbers. And then what you do next is the middle guy, the 7x, we're going to split it up into 3x and 4x from here, plus 12. And there we go. That's step number 1. Step number 2, we're going to factor this 2 things at a time. Between x squared and 3x, what can we pull out?
An X.
Right. What are we left with in a bracket?
X plus 3.
Yeah. From the next, again, the sign drops. Okay, this is going to drop. If it's a plus, it's going to drop as a plus. From these two, what can we pull out?
A 3.
4x and 12, probably not a 3. 4x and 12, a 4, right? A 4, not a 3.
Oh, okay.
What's left in the bracket?
X plus 12.
Not 12. We took out a 4, right? X
Plus
plus
3.
3, yeah, exactly.
Okay.
And notice these two brackets will always be the same. Now we're going to pull
Mm-hmm.
out that entire bracket, okay? We're going to pull out the entire bracket. We're going to pull out x plus 3. What are we left with in the other bracket?
The same.
No, not the same. We took out x plus 3, okay? We're left with x plus 4, and that's what goes in the other bracket.
Oh, okay.
Okay, now why is this powerful? Notice this is x power 2. It is no longer a linear function. This is what we call a quadratic. The shape looks like a parabola. It's a U-shaped figure. When you factor this as we did. And when you set it equals to 0, you get two different equations. X plus 3 equals 0, x plus 4 equals 0. Solve for x, you'd get -3 and -4. Those are the x-intercepts of this diagram, basically. Those are the x-intercepts. So that's when it crosses the x-axis at -3 and -4. Okay?
Okay.
So when you factor it, it's going to give you the x-intercepts. Let's try another one. This man method only works for a quadratic trinomial. Quadratic means x power 2, and trinomial means there's 3 terms in the expression, 1, 2, 3. When you see something like this, to factor this, you're going to have to use the man approach. And let's do it for this question. What do the two numbers multiply to? It multiplies to the coefficient between the first term and the third term. Okay?
Mm-hmm.
So what does it multiply to? 1 times -6. It's -6. Okay?
Uh-huh.
And it's going to add up to the coefficient of the middle term, the x term. What's the coefficient of the x term? What's the coefficient of this term? Coefficient just means the number. It's -1.
-1.
Yeah, exactly. So multiplies the first and third always and adds up to the middle one, okay? So what
Mm-hmm.
are the numbers that satisfy these conditions? Two numbers that multiply to -6 and add to -1. You want a hint? One of them is 2. The other one is -3.
Oh, okay.
So -3 times 2, -6, -3 plus 2, -1, okay?
Mm-hmm.
And then we're gonna split apart the middle term into those two. So x squared minus 3x plus 2x, and it comes from here, -3x, 2x, -6. What can we pull from the first two terms?
X.
Yeah. What are you left with in the bracket?
X -3.
Good. What can you pull out from the next two?
A 2.
Yeah. What are you left with in the bracket?
X -3.
Right. X minus 3. Notice these two brackets will be the same. Now we're going to pull out that entire bracket of x minus 3. What are we left with in the other bracket?
X +2.
Yeah, x plus 2. And you're done, okay?
Okay.
The hardest part is coming up with the numbers, but as you do this, it's going to come quicker and quicker. Because there's only two things that multiply to 6. It's either 1 and 6 or 2 and 3. 1 and 6 would not add up to -1 in any way. So it must be 2 and 3. And 3 is negative because it's adding up to a negative number. Let's try another one. All right, same kind of question. We're trying to factor this expression. It's a quadratic trinomial. We're gonna use the man approach. Can you tell me what do they multiply to?
A 6.
Yes. What does it add up to?
A 7.
Yes. So what are the numbers that multiply to 6 and add up to 7? So you can think about it. There's only two things that multiply to 6. One of them is 2 and 3. There's no way that adds up to 7 in any combination. The other one is 1 and 6. Does that add up to 7?
Mm-hmm.
Yes, yes, it does, right? So those are our numbers. Cool.
Uh-huh.
And then we're just gonna put this. So it's just gonna be 2x squared plus 1x plus 6x plus 3. We can pull out an x from the first. What are we left with in the bracket?
X plus 1.
Yes, not just x though. You're gonna be left with 2x in the first bracket, right?
Oh,
2x plus 1. The plus sign drops. What can we pull out from the next two terms?
A 6.
Nope, 6 does not go into 3. Try again.
A 3.
A 3, yes. What are we left with in the bracket?
X plus 1.
2x plus 1. There's 6x. We take out a 3, or left with 2x, okay?
Oh, okay.
And then you can pull out that entire bracket, 2x plus 1 and x plus 3. There we go. And now we've factored it.
Mm-hmm.
Okay, so the man method is for a quadratic trinomial. But you might not always get a trinomial. Sometimes you get a quadratic binomial. It means there's only two terms. You can still factor them though. An example would be something like this: x squared minus 36. Now this is a quadratic binomial. Quadratic because it's x power 2, and binomial because there are two terms in the expression. Now, the goal is to factor this, and it is possible to factor this. How do we go about doing that? You're going to use a formula. So this is not going to use the man approach. This is called a difference of squares. Difference of squares. What is that? If you have something in this form, a squared minus b squared, this will factor out to be a minus b times a plus b. Or you can write the plus term and make this minus. It doesn't matter which one you put first, but this is what it factors out to. So this expression, step 1, we're gonna write it in this form. Well, x is already squared. What's 36 the square of?
6.
Yes, so we're gonna write it as x squared minus 6 squared. And we're gonna use the formula. So it becomes a minus b. We know a is x and b is 6. So x minus 6 times x plus 6, like that.
Okay.
Okay. It does get a little bit difficult though. The formula will be exactly the same. Now look at this. 4 minus 9y6. Now that is also a difference of squares. Now the question is, what is 4x4 the square of? What do you think? Something squared is 4x4. In other words, what is the square root of 4x4?
2x to the power of 2.
Yes, 2x to the power 2. What about 9y6? What's the square root of that?
3y to the power of 3.
Yeah, that's exactly right. You just chop the expression in half, and then you would get 2x squared minus 3y3 first term, and the next term would just be the same thing with a plus sign, and you're done. Okay,
Okay.
so that's how you factor a quadratic binomial.
Do we end up like doing it backwards?
How do you mean? So yeah, that can always happen, right? So they might give you this, and they might ask you to FOIL this to get this back. It does happen, okay? Like, for example, quadratics, it has 3 different forms. This one is the standard form, means it's just how it is, okay? It's just, this is how you plot it on Desmos or something. And this thing is called the factored form. So they both have their own uses. Factored form gives you the x-intercepts. So if you're looking for x-intercepts, you want to go into the factored form. The standard form, it gives you the y-intercept. So if you want the y-intercept, you want to kind of work your way backwards into this, okay? But factored form is way more powerful than the standard form. It gives you a lot more information. All right, let's kind of put this together. Let's look at this expression. And that's the expression, and these are the questions. Step 1, let's factor this expression. Can we factor this? Can we pull anything out? What can we pull out from both the terms? And it is factorable. You can pull something out.
5.
Or a -5. Okay.
Mm-hmm.
What are we left with in the bracket?
T squared plus 4.
Okay, now it's not going to be t squared plus 4 because we pulled out a -5, right? 20 over -5 is a -4, you see?
Mm-hmm.
And that is factored, but we can go one step further. If you notice in the bracket, we have a difference of squares. How do we factor that? So again, that's a difference. It's in this form. If you notice, how can we factor out that bracket? It's going to turn into 2 different brackets.
So
Using
t minus 2 and
yeah,
then t plus 2.
that's exactly what it is. Okay, that's exactly. Now we've factored this. Now let's see. Let's kind of put it all together. Part A says draw a graph. Okay, it says draw a graph. So we're just going to give them a graph. What's the independent variable here? We have time. T represents time. H represents the height of a diver. He's jumping off a cliff, like boom. What do you think is the independent variable, height or time?
Time.
Time is always going to be the independent variable, okay? So on the x-axis, we have time, t. On the y-axis, we have height, h. Okay, now, if you look at this expression, there's no brackets or anything. That's a quadratic in its standard form, and that gives you the y-intercept, plus 20, the number that's by itself without any variables. 20 is the y-intercept. Okay? 20 is the y-intercept. And you see t minus 2, t plus 2. If we set them equals to 0, that's going to give us the x-intercepts. If t minus 2 is 0, what's t? T
Is it
minus,
just 2?
yeah, it's just 2. And similarly, t plus 2 equals 0, t would be minus 2. Okay? So those are our x-intercepts. So we have a plus 2 here, and we have a minus 2 here. Okay?
Okay.
Anything powered 2, it's a quadratic. It looks like a U. Okay? But if there's a negative sign on the outside, you see this negative? Instead of going up, it's gonna be upside down. Okay? It's upside down U. It's because of the negative sign. It's basically been transformed. It's flipped on the x-axis, we call it. And now we're just gonna join the dots. We know -2 is our x-intercept. We know 20 was our y-intercept. And we know positive 2 is our another x-intercept, boom. And that's the graph. Okay?
Okay.
Let's answer the other question. B, determine the height from which he jumped from. What do you think the answer is? We have it. We have everything.
20.
Exactly. That's the y-intercept. He jumped from a height of 20 meters or whatever the unit is. Determine when the diver will enter the water. So after how long is he going to hit the water? We already have this as well. Right here. How long did it take for the height to be 0 is what they're asking. They're just asking for the x-intercept. Time cannot be negative, so we can ignore this. The answer is after 2 seconds, he's going to hit the water.
Mhm.
Does that make sense?
Uh-huh.
Right, so that's kind of like putting everything together. In quadratic, you see this all the time. Anytime you see like an arc, someone throws something, someone dives, we see this all the time. Let's try another one. And this time it's not a difference of squares. This time it's a trinomial. It's a very similar question. Let's try this. So we have this expression. Step 1, let's factor this, okay? And it's always helpful if you can pull something out in the first step before you even man it. And we know this is a man question because it's power 2, meaning it's quadratic and there's 3 terms. So step 1, let's see if we can pull something out in the very beginning, because that's going to make our life a lot easier. Can we pull something out here? What do you think?
A T.
Not a t, because 75 doesn't have a t. We can't pull out the t.
Oh, a 5.
A -5. Okay, let's pull out a -5. We're going to pull out whatever that is. If we pull out a -5, what are we left with in the bracket is the question.
T squared plus 2.
So there's going to be 3 terms in the bracket, okay? The first one's going to be t squared. The next one, we're pulling minus 2t, and there's going to be one more. 75 over -5, that's 15.
Minus 15.
Yeah, there we go.
Okay.
So that's our expression, okay? And now we can man this. It's way easier to man this than not. Because before we were really looking for numbers that multiply to like 300 something. We don't want to be doing that. This one is way easier. So we're looking for 2 numbers that multiplies to 1 times -15, -15, and that adds up to -2. What are the 2 numbers?
Is it -5 and 3?
Yeah, that's exactly what it is. -5 and +3, okay? And now we can kind of factor this. It becomes t squared minus 5t plus 3t minus 15. Next step would be to break down the 2t into these two, and we're going to factor this by grouping. What can we pull out from the first 2 terms here?
A T.
Yes, and what are we left with in the bracket?
-5 plus 3.
No. We're pulling out a t from these 2 terms, okay?
Oh.
We would be left with t minus 5. Yes? It's like a bracket within a bracket. From the next 2 terms, again, this sign will always drop, so plus. Between 3t and -15, we can pull out a 3, yeah? What are we left with in the bracket?
-5.
There will be a -5, yes, but we're pulling 3 out from 3t as well. It's going to be t minus 5.
Oh, okay.
Does that make sense?
Mm-hmm.
And now we can finally put it all together. We can pull out the t minus 5, and then we'll end up with t plus 3. And there we go. It's factored now, okay? Let's answer this question part by part. How high is the cliff? So they're basically asking you for the y-intercept. You can just look at the equation in its standard form for the y-intercept. What is it?
75.
75 meters, yes. Now this part is kind of difficult and we haven't really done this. Step one, to do part B, we're gonna have to find the vertex. That's basically what it is. Quadratic, the y-intercept might not always be the vertex, okay? You can always have, and again, I know this was upside down because of the negative in front of 5. You can also have something like this. Well, this is a y-intercept, but it's not the maximum. Look at this, compare this with this. Here, the y-intercept is the maximum height, or the pointy, the edge, the vertex. But in this graph, the y-intercept is not the maximum. There's another point here. And that thing is called the vertex. Okay?
Mm-hmm.
Now, how do you find the vertex is the question. To do that, you're gonna have to do two things. To find the vertex, step one, find the midpoint of the x-intercepts. What are the x-intercepts here? Look at the equation. Are you able to tell what the x-intercepts are? Looking at these two, you just want to set them equal to 0, okay? In fact, the sign flips, that's all there is. T equals 5 is one of them, and t plus 3 equals 0, t equals -3 is the other.
Mm-hmm.
Those are the x-intercepts. You just flip the sign in the factored form, or you can set the individual brackets equal to 0. And to find the midpoint, you just add them up, and then you divide by 2. Midpoint just means you just add them up, divide by 2, okay? So
Mm-hmm.
5 plus -3 is 2. 2 over 2 is a 1. There we go. The midpoint is 1. Cool. So when does the rock reach its maximum height? After 1 second. That's all there is.
Okay.
So in this question, instead of just straight up diving down, we're tossing it up, okay? This is the cliff. We're gonna toss the rock up and then it's gonna come crash in the water. Look at part C. What's the rock's maximum height? To do this, you need the midpoint of the x-intercept. We already have it, yeah? You see that? 1.
Mm-hmm.
To find the maximum height, well, you just plug this back into the equation. So to do part C, you just plug 1 as t. So we have -5 times t squared, so 1 squared, plus 10 times 1, plus 75, like that. And that's going to give us an 80 if you plug that in a calculator. Okay?
Okay.
So putting it all together, we can kind of graph this. We know our two x-intercepts is -3 and +5. We know our y-intercept was 75. And we know the maximum height happened after 1 second. The maximum height was 80, and this is our vertex. And we can just connect them all together. So it's gonna look like this. It's gonna go to its maximum height and it's gonna drop down. Okay, that's gonna be the graph. In a real life scenario, we're not really interested in this quadrant because time will not be negative. So you can kind of like ignore this part if you want to. But not
Okay.
always, okay? Not if there's a time, yeah, you can ignore this. And you can also ignore this bit. And that basically tells you everything. Y-intercept is 75. After 5 seconds, it's gonna hit the water and the maximum height is 80 after 1 second. Cool?
Mm-hmm.
So you see it's very powerful quadratics, power 2. Let's see what else they got for us. I kind of want to do another word problem. All right, let's try doing this one. This guy looks very funny. It's like in a real life problem. So what's going on here? So their profit, P is the Y axis, the Y value. X is the X value. What does it represent? X represents the number of games and P represents the profit. All right. Difficult question. Not really. Let's try and factor this. Factoring it is always good. question 1, or the first question you want to ask yourself. Can we pull something out to begin with? Because that's going to make our man life a little bit easier. What do you think? Can we pull something out right now? Do they have anything in common? They do not, okay? If this was an 8 or something, we could have pulled out a 4 or a -4, but as it is, we can't pull anything out. Now the question is, what do they multiply to? We're looking for a set of numbers. They multiply to something. What is that number?
Positive 36.
Good, positive 36. What does it add up to?
20.
Yes. What are the numbers that multiplies to 36 and adds up to 20? One of them, well, if you think about 36, you can either have 12 times 3, 4 times 9. That'll never add, neither of these will ever add up to a 20. I'll give you a hint. One of the numbers is a 2. One of the numbers we're looking for is a 2. What's the other number?
Um,
18. Okay. If I give you one number, you can just subtract it from 20 to get the other number, and that's you. There you go. So 2 and 18 adds up to 20, multiplies to 36. Next step, we're gonna break down the middle thing. So negative 4x squared plus 2x plus 18x minus 9, like that. Now we're gonna factor this 2 things at a time. Look at the first 2 terms. What can you pull out?
A 2.
Yeah, what else?
An X.
Yes. In fact, we're gonna pull out -2. Okay? We're gonna pull out -2. What are we left in this bracket?
X plus 1.
Okay. X, nope, try again. It's not x plus 1. Both of these are wrong. This is wrong, and this number is also wrong. It'll be 2x minus 1. Right? Look at this. We had 4x squared, negative 4x squared. We pulled out a negative 2x. This x cancels out with one of the x's, and negative 2 goes into the negative 4 2 times. Okay? So we can 2x, and then 2x over minus 2x is -1. And that's, we're done with the first bracket. Let's look at the next 2 terms. What can we pull out between 18x and 9? Can pull out a 9, okay? What goes in that bracket? We're pulling a 9 out of these. We're pulling a 9 out of these 2, okay? 9 times 2x is 18x, and 9 times -1 is -1. Basically, if you have this bracket, you automatically have this bracket, but they will always be the same. Cool? Now we can just kind of put everything up together. So we get -2x plus 9, and then we pulled out the other bracket, 2x minus 1. Cool? A little bit difficult, right? Yeah, a little bit difficult in the factoring. Once you have this, we can find the x-intercepts, okay? We can find the x-intercepts. To find the x-intercept, you just kind of want to set it equal to 0, the individual brackets equal to 0. This, and then we're going to put the other bracket in equal to 0 as well. How do we solve the first equation for x?
You subtract 9.
Yes. And then you divide by -2, yeah?
Mm-hmm.
So you get 4.5 or 9/2. You do the same thing on the other bracket, you get 0.5. Cool?
Mm-hmm.
All right, there we go. That's all we need for this question. Now let's kind of graph it. Actually, they want the maximum profit. That means they also want the vertex. Okay. To find the vertex, what do we do if you remember? You want to find the midpoint, okay? Whenever you see this word maximum or minimum, step 1, just find the midpoint of the 2x intercept. So the midpoint is you just add them up literally and divide by a 2. So 4.5 plus 0.5/2, that will be 2.5. Okay?
Okay.
So this is when the maximum happens. And if you actually want to find the maximum value, you can just plug this back into the equation. So -4 times 2.5 squared plus 20 times 2.5 minus 9, like that. So let's try that. -4 times 2.5 squared plus 20 times 2.5 minus 9, and that's 16. Okay?
Okay.
And now let's graph this. So we know the 2x intercept is positive 0.5 and positive 4.5. That's the 2x intercepts. Look at this equation. Where's the y-intercept? The y-intercept is just a constant. Yeah?
Mm-hmm.
What's the constant here? The one that doesn't have an x attached to it.
A 9.
-9. Okay?
Mm-hmm.
I'm going to pretend this is -9 here. There you go. That's the y-intercept, and we had the 2x intercepts. Where's the vertex of this equation?
2.5.
Yeah, at 2.5, which will be right in the dead center. We have a vertex, and that value is 16, right?
Mm-hmm.
16, so somewhere there. And there we go. We're just going to join all the dots together. Goes up, and what goes up must come down. And we know it was going to be an upside down. Now, again, in most of these real life questions, it's going to be upside down mostly, but not always. And you could straight up tell if something is upside down or not by looking at the sign in front of the quadratic. If it's negative, it must be upside down. If it's positive, it's a normal U. Okay?
Uh-huh.
So now let's look at the question. On the y-axis, we have profit. On the x-axis, we have the number of games. The question's asking us, what's the break-even point? Break-even means the profit is 0. They're neither making money nor are they losing money. When is the y value 0? Y value 0 on the x-intercept, okay? See
Mm-hmm.
right here, these are one x value. So the break-even point is 0.5 and 4.5. And it's 100,000, so hundreds of thousands. So either they make 0.5 hundred-thousand or they make 4.5 hundred-thousand, and they will not lose any money. Cool?
Mm-hmm.
B, what's the maximum profit they can earn?
Is that the 2.5 and
So
16?
the maximum profit is the y-axis. Yeah, it's 16.
Oh, okay.
16, and it's million, because it says here profit is in millions. So 16 million is the maximum profit. How many games should they sell to get that maximum profit?
The 2.5.
Yeah, exactly. So 2.5, 100,000, okay? Because that's the unit here in 100,000. So if they sell 2.5 100,000 games, they will make a maximum profit of 16 million, right?
Mm-hmm.
So you see, it's very useful in real life data modeling. Kind of helps you find out the maximum, basically, to optimize your business or whatever. All right, let's call it a day there. We'll pick it up next time.
All right. Thank you.
Bye-bye.